In the last lessons, we learned about pH as the pH scale that starting from 0 all the way to 14, and in the middle we have 7. That is the pH of your pure water. And then we talk about the relationship in terms of the letter P, how P is related to the negative log. And today we are going to talk about how can we go from pH or P of anything to solve for the concentration of that anything. But first, let's look at pH. Well, if we have P of anything, like pH, that is referring to P to the concentration or P of the concentration of H. And what is H in this case is your hydronium ion, which is H plus right there. Okay? So we have P of anything is basically equal to the negative log to the base of 10 of the concentration of H plus. So keep that in mind. P of the concentration of anything is equal to the negative log with a base of 10 to the concentration of that anything. Now if we look at in terms of pH, of course we're going to have negative log of H, and that is the concentration of H plus. The question is this: how can I solve for the concentration of H if I am given pH? So we had to go backward in a way that we can solve for this concentration. Well, that's very easy based on these rules right here. Okay, so first of all, we need to go back and bring the negative signs over here, and that will give us negative pH equal to log with a base of 10. So we have negative pH equal to the log base of 10 to the concentration of H plus. That's basic math right there, right? Now we are going to use this rules of log right there, because 10 to the log with a base of 10, so you have 10 and 10, they cancel each other out equal to 1. If that's the case, can I just put 10 to the power of that whole entire thing, and I would do the same thing to over there. So this now is going to be equal to 1. So we would have 1 times the concentration of that H plus. But now let's use in terms of anything, because we're not only dealing with pH, we're also dealing with pOH, pKa, pKb, and pKw. So this can be solved. All this right here can be generically represented in terms of anything. Okay, so any of these will be applicable to here. So let's rewrite this in terms of something that we can see and apply to all these right here. So of course in this case I have 10 to the power of negative pH equal to the concentration of H plus. Right. Now if I were to interpret this in terms of anything, of course I would have 10 to the power of negative P of anything equal to the concentration of anything. Isn't that easy? And this can be applicable to all these up here. So let's look at this particular problem together. How about that? Then we also have the relationship in terms of concentration. Look at the pH scale from 0 to 14. Of course, you take the concentration of your H plus times the concentration of your OH minus, and that will give us, or 10 to the negative 14. And it makes sense, because if we look at this right here, we take the negative log of 10 to the negative 14, what is that going to give us? Of course that's going to give us 14. So there are a bunch of patterns that allow us to memorize relationship. The same thing for Ka and Kb, time, that give us Kw, which is equal to 10 to the negative 14. If the pH is 7.0 at 25 degrees Celsius, calculate for the concentration of H plus, pOH, and the concentration OH minus for the sample. So of course what we have here is pH equal to 7. So let's rewrite that. pH equal to 7. Okay. Then if we want to solve for the concentration, we're going to use this knowledge, right? that the concentration of anything is equal to 10 to the power of negative p of anything. Well, in this case, that pH is right there. So all you have to do is the concentration of H is equal to 10 to the power of negative 7. Because 7 is your P of anything. Well, in this case, that anything right here is actually your concentration of H. Exactly as we have here. And that's all you really have to do. What about for pOH? Of course, we know the relationship for pH and pOH is that when you add both of them together, pH plus pOH is equal to 14. So in this case, your pH plus pOH equal to 14. So your pH is 7. Of course, pOH is gonna equal to 14 minus 7, and that's gonna give us 7 as well. Isn't that easy? What about the concentration of OH? Again, we have this relationship right here. The concentration of anything is equal to 10 to the power of negative P of anything, which in this case, this anything is your OH minus, right? See how that changed over time? So of course the concentration of OH minus is equal to 10 to the power of P anything. In this case, P anything is pOH, which is 7, so 10 to the power of negative 7. Because this 7 is your pOH, which is P of anything. So isn't that easy? And how can we prove that? This really worked. We have to realize that this is the relationship right here. Let's look at in terms of concentration. So if I were to look at this, concentration of H plus times the concentration of OH, it must be equal to 10 to negative 14. Is that really happening here? Well, I have that right there, and I have that right there. So OH plus times OH minus in terms of concentration equal 10 to the negative 14. Is that really happening here? Well, let's look at this. 10 to the negative 7 times 10 to the negative 7. Well, the base is the same, so you just add them together, which turn out to be 10 to the negative 14. And there you go. And that's how you prove that it's actually working. And now let's try another problem. Relative to a pH of 7, a solution with a pH of 4 has how many times greater concentration of H plus than the solution of pH 7? Of course, pH of 4 would has a lot more concentration of H plus because it was more acidic over here. That means right here it was acidic. That tells you that the concentration of H plus is a lot greater than the concentration of OH minus. Whereas over here it was basic. What do you think is going to happen? Of course, it's going to be the opposite. When you think of the term base, right? Arrhenius base is basically producing OH minus. So in this case, the concentration of OH minus will be greater than the concentration of H plus. And that is what gives us a basic condition. Where over here, give us our acidic condition. What do we have neutral? Let's use a common sense. Of course, the H plus concentration will be equal to the concentration of OH minus. Isn't that easy? Now let's get back to this problem. How about that? So pH of 7, pH is equal to 7, okay? Of course, the concentration of H or H plus is equal to 10 to the power of negative P of anything, which is pH. So we have 10 to the negative power of P anything, which is pH, so 10 to the negative 7. And then for pH of 4, pH equal to 4, of course, the concentration of H plus here is equal to, again, 10 to the power of negative P anything, which in this case is pH. So 10 to the power of negative pH, so 10 to negative pH, which is 4, so we have 10 to the negative 4. Now, if we have this two number, how do we determine in terms of how many times greater in terms of concentration of H plus? Well, let's use a common sense. We know that to get from negative 4 to negative 7, What do we need? -5, -6, and -7. So how many 10 to the power is that? That's going to be 3 times. So 10 to the 3 times is equal to what? Of course, it's going to be 30, and that is going to be 1,000 times. So keep that in mind. Isn't that easy? Don't get tricked by this problem. It is extremely easy. Now let's get to Ka. So we have Ka, okay, and we want to calculate for pKa, Kb, and pKb. So in this case, to get from Ka to pKa, that's pretty easy. P is equal to what? Negative log. And well, in this case, it's negative log of Ka. So we have negative log of Ka, which is 7.0, times 10 to the -9. And that will give us what? Well, if we plug this into a calculator, you have to realize that you have to plug in the correct manners. Because you plug it wrong, it will change everything. Remember, in your calculator, there's a button called EE or exponent, right? In this case, I have EXP here. That represents times 10 to the power. So that way, if you use a button, don't type 10 again. So we have negative log 7, and I'm going to use EXP -9. And that gives us what? Equal to 8.15. And that's equal to your pKa. And how do you solve for Kb? Well, before we solve for Kb, let's solve for pKb. Because we know back here, just like pH and pOH equal to 14, pKa and pKb equal to 14 as well. So that's easy math, right? So in this case, we have pKa plus pKb equal to 14. This is 8.15. So your pKb must be 14 minus 8.15. And of course, if we plug this into a calculator, your pKb is equal to 5.85. Isn't that easy? Now from there, of course, if we want to solve for Kb, remember going back to that relationship, the concentration of anything is equal to 10 to the negative P of anything. Well, in this case, we don't look for concentration, we're looking for Kb right there, right? So we know it's going to be 10 to the power negative of anything. In this case, that anything is Kb. So in this case, we have negative P of anything, but specifically, it's going to be P of. So remember, we have 10 to the power of negative P of anything. In this case, that anything is Kb. So our Kb is right here, so which is at 585. So 10 to the power of negative 585. That will give us our Kb. Now let's prove if that really happened. Because we know that Ka times Kb in terms of concentration is equal to Kw, and that's equal to 10 to the negative 14. So let's prove that. We have Ka, which is 7.0 times 10 to the negative 9, times your Kb, which is 10 to the negative 5.85. And does that really happen to be equal to 10 to the negative 14? Let's check. Let's plug this into our calculator. 7.0 exp negative 9 times 10 to the power of negative 5.85. And look at that. We have 9.89 times 10 to the negative 15. You think about that. Isn't that about 10? So if you think about this, isn't this about 10? So that will decrease this by 1. So therefore you have negative 14. So this is an estimation of 1.0 times 10 to the negative 14, which is exactly equal to that. And that's how we change from pH to the concentration, or in terms of pKa, pKb, in terms of concentration, or the concentration of H plus or OH. And that's all we have to do. Isn't that easy?